Dear students, good morning. Today we are going to start another chapter, gravitation, which is very important and interesting chapter. In the previous chapter we have studied that a force is necessary to make a body move. That is, force is necessary to produce a motion in a body. This is a duster. This duster will move from this point to that point if I will apply some force on this duster. If I am not applying any type of force on this duster, then this duster will not move from this point to that point. So force is required to produce motion in our body. Now if we drop a piece of chalk, this is a piece of chalk from some height, the chalk falls down towards the earth. It means it means a force must be acting on it. This force is due to the attraction between the earth and the stone, and it is called the gravitational force of earth or gravity of earth. I am not applying any type of force on this chalk, but this chalk is going towards the earth. It means earth is applying some force on this chalk, and this is known as gravity of earth. It is said that once the great English scientist Sir Isaac Newton was sitting in his garden under an apple tree, when an apple from the tree fell on him. Newton said that an apple falls down from the tree because earth exerts some force of attraction on the apple. Later on he discovered that there is not a force of attraction only between this apple and the earth, this piece of chalk and the earth. Everybody in this universe attract each other. This is a pencil, this is a duster. There is a force of attraction between these two objects. There is a force of attraction between these two dusters. There is a force of attraction between this building and that building which is outside. But the question arises, if there is a force of attraction between this building and that building, and there is a force of attraction between these two dusters, then these two dusters must collide with each other. But this is a very weak force, so we cannot observe the force of attraction between these two objects. If one body is very heavy, the mass of one body is very large, for example earth and this pencil, then you can observe the acceleration, then you can observe the motion between the earth and this object. Now today we are going to start universal law of gravitation. What is universal law of gravitation? According to Newton, everybody in this universe attract each other with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. He said that everybody in this universe attract each other with a force which is directly proportional to product of their masses and inversely proportional to the square of distance between them. Consider two objects. One object is A and another object is B. And these two objects are separated by a distance r, and let mass of this object, let it be m1, and the mass of this object, let it be m2. So force of attraction is directly proportional to the product of their masses. The mass of this object is m1 and the mass of this object is m2. Product of their masses means m1 m2, equation number 1. And the force of attraction between these two objects is inversely proportional to square of distance between them, 1 upon r square, equation number 2. So on combining 1 and 2, F proportional m1 m2 upon r square. So this is a sign of proportionality. There is a constant F, it is equal to G m1 m2 upon r square. So where G is a constant, where G is a constant called gravitational constants. So where G is a constant called gravitational constant. Now come to units of gravitational constant. We know that F is equal to G m1 m2 upon r square. Now find out G. After transposing, you are getting F into r square upon m1 m2. Or G is equal to unit of force, Newton. What is R? It is the distance between two objects. So SI unit of distance, meter square. M1, mass of first object, kilograms. SI unit of M2, kilograms. So therefore G is equal to Newton meter square upon kilogram square. Or even you can write down G is equal to Newton meter square kilogram kg minus 2 Newton meter square per kilogram square. Now come to one more thing, that what is gravitational constant, that is definition of gravitational constant G. We know that F is equal to G m1 m2 upon r square. Then find out G. G is equal to, after transposing, this is equal to F r square upon m1 m2. So m1 is equal to m2 is equal to 1 kilograms. Take distance between the two objects 1 meter. Put these two values here in this equation, then you are getting R is equal to G is equal to F 1 into 1, or G is equal to F. So G is equal to F. Then now you have to define G, gravitational constant. Look at these three things, 1, 2, 3. What is this? Gravitational constant. What is this? Is equal to. F means force of attraction between two objects. And keep in your mind these two things. And now you define. Gravitational constant is equal to the force of attraction between two bodies of masses, each of mass 1 kilogram and separated by a distance 1 meter. So gravitational constant कोई नई चीज नहीं है. This is a force of attraction between the two objects. One object m1 and 2. The mass of this object is 1 kilograms. और इन दोनों के बीच डिस्टेंस कितनी है? 1 मीटर. तो इनके बीच जो फोर्स ऑफ अट्रैक्शन होगी उसी का नाम ग्रेविटेशनल कांस्टेंट है. सो ग्रेविटेशनल कांस्टेंट, इट इज द फोर्स ऑफ अट्रैक्शन बिटवीन द टू ऑब्जेक्ट्स, ईच ऑफ मास 1 kilogram and separated by a distance of 1 meter. And in this law, this is very important law. First of all, definition, this figure, then this simple derivation, then come to units of gravitational constant. You can try units just like this one. So G is equal to unit of gravitational constant is equal to Newton meter square per kilogram square, and this is the definition of G. कई बार क्वेश्चन आता है, why this law is known as universal law of gravitation? Because this law is applicable everywhere. On the surface of Earth, below the surface of Earth, anywhere, any planet, in any star, this law is applicable everywhere. So this law is known as universal law of gravitation. Thank you.